Now, this is a particularly difficult question because it involves 3D trigonometry in a way that people aren't really familiar with. We'll start with the first question. The angle of elevation of T from B is 19 degrees. And the angle of elevation is the angle that B to T makes with the horizontal, so it means that that angle there is 19 degrees. And then it says calculate the length of AT. Well, BAT is a right angle triangle, so if I take get my lines up, so that's BAT. I can draw that out here. It looks like this. And so we've got T here, we've got A here, we've got 50 here, we've got 19 here, and we're trying to work out the length of AT. Well, this is a right angle triangle. BA, the marked length, is the adjacent to this angle. And this is opposite to this angle, so which trigonometric ratio uses opposite and adjacent? So TOR. It's tan, so we'd say tan 19 equals opposite over adjacent. Call this x here. So therefore x equals 50 times tan 19. Careful, it's not always the trigonometric function times the number. It depends on whether x is on the top or the bottom. But if we multiply both sides by 50, this is what we get. And 50 times tan 19 is 17.2. Okay, then it says calculate the distance from C to T. Now, C to T is a much trickier proposition altogether, and it takes a bit of visualization. Imagine that, now it says ABCD is a horizontal rectangular field. So field's a bit difficult to picture. Imagine that this ABCD is the base of a cardboard box. Okay, now it's a rectangular cardboard box. It's 50 units across. Let's say that's centimeters, and it's 27 centimeters wide. So if you're looking down at this base, I know it looks like a parallelogram at the moment, but it's just for the perspective point of view. It is a rectangle, and so if you've got the base of a cardboard box and you wanted to find the diagonal of the cardboard box, you'd just use Pythagoras, right? You'd say this length here from A to C. To work it out, we can just do 50 squared and 27 squared, add them up, and then square root it. Okay, so if we do that, we get if we add them and square them, we get 3229. So that's the square root of 3229. Okay, now here's the bit that you have to find. It's going to be difficult to visualize. Now suppose at the end of one end of the cardboard box, we stick a pencil. So the pencil is vertically upright. And from the top of the pencil, we now attach a string going diagonally across the cardboard box to point C. Yeah? So ABCD is the base of a cardboard box. We've got a pencil fixed up here, and we're now going to attach a string from the top of the pencil to point C. This is going to stretch your powers of visualization. So there's our string there. Now, think about the triangle we've got here. We've got the line going along the diagonal of the box, meeting the pencil, going vertically up, and then we've got the string connecting the top of the pencil to the corner here. Now, this is a right-angled triangle. You might be thinking, I don't believe you. Well, just imagine that the pencil fixed on the base here. The pencil is vertical. This line here, although it's going diagonally across the box, if you lay the box flat on the ground, that line is a horizontal line flat on the ground. And so any vertical point standing on the ground is going to be perpendicular to a horizontal line. So this is a right angle here, and that's the most important thing to visualize about this question. So ATC is a right angle triangle, and once we know that, the question is not too difficult to solve, because we already know what AT is. We just worked that out. And again, don't use the rounded version of AT in a question like this, because in the second part, because it will mess you up. Don't use 17.2. Use 50 tan 19, which is the proper value of AT. Here's C. And we know that this length here is the square root of 3229, is it? Yes. So now to work out the length TC, the length of our string attached from the top of the pencil to the other corner, which is the length that we wanted to work out, we square this, we square this, we add them together and we square root. Obviously the square of this is just going to be 3229. We square the other thing, add them up. So CT squared equals 50 tan 19 squared, not 17.2 squared, remember, because that's going to leave us with rounding problems, plus 3229, the square root of it squared is just going to be 3229, equals whatever it equals, and if you square root that, you get 59.37, which rounds to 59.4.